Serverless was sold as the ultimate architectural dream: zero management, infinite scale, and most importantly, zero cost for idle time. It promised a world where you only pay for the exact milliseconds your code is running. But for many growing engineering teams, the reality is a monthly invoice that grows faster than their actual user base. The pay-as-you-go model has a dark side, a series of hidden taxes that kick in the moment you move beyond a hobby project. Today, we're dissecting the specific components that turn serverless from a cost saver into a financial burden, and identifying the exact tipping point where you should probably be running a traditional server instead. The first silent killer of your budget is the entry point, the API gateway. In a traditional setup, a load balancer costs a flat monthly fee plus a small amount for data processing. In serverless, you're often charged per million requests. At 100 million requests per month, an AWS API gateway can cost around $350. A standard application load balancer handling that same traffic might only cost $20. You are paying a 1,500% premium just for the convenience of not managing a listener. This is acceptable for a low-traffic MVP, but as your microservices start talking to each other internally, these per-request costs compound exponentially. Every internal hop becomes a billable event. Then there is the networking trap. To make your serverless functions secure, you likely put them in a private VPC, but those functions still need to talk to the internet, to fetch an API key, send an email, or connect to a managed database. In AWS, this requires a NAT Gateway. You pay an hourly rate for the gateway itself, which is fine. The scam is the data processing fee. NAT gateways charge roughly 4.5 cents per gigabyte. If your function is processing large images or heavy JSON payloads from S3, you are being double billed, once for the Lambda execution and once for the privilege of the data passing through your own virtual network. For high-throughput data processing, the networking bill often eclipses the compute bill entirely. Serverless promised you'd never pay for idle, but then you hit cold starts. The first request to an inactive function takes seconds to initialize. For user-facing APIs, this is unacceptable. To solve this, cloud providers offer provisioned concurrency. This keeps a specific number of execution environments warm and ready. The catch? You pay for those environments 24/7, whether they are used or not. By enabling provisioned concurrency to fix your latency, you have effectively turned your serverless function back into a server, except it's a server that costs significantly more than the equivalent EC2 instance or container. You've lost the primary economic benefit of serverless while keeping all of its architectural constraints. So when is serverless actually a scam? It's all about the tipping point. Serverless is magnificent for three things: low-volume tasks, highly unpredictable spikes, and cron jobs. If your service has a steady baseline of traffic, say more than 50 requests per second, you are almost certainly overpaying. At that scale, a small cluster of containers on Fargate or even basic virtual machines will be 70 to 80% cheaper. The goal isn't to avoid serverless entirely, but to treat it as a specialized tool for bursts, while moving your consistent heavy workloads to provisioned infrastructure. Don't let the convenience of a no-ops marketing pitch blind you to the architectural tax you're paying every single month.